Moliverse, contextually embedding the microcosm into the universe. We present Moliverse, an integration of the molecular visualization framework VMD into the astronomical visualization software OpenSpace, allowing us to bridge the two extreme ends of the scale spectrum to show, for example, the gas composition in a planet's atmosphere. Moliverse is a combination of two visualization systems, one for AstroVis, OpenSpace, and one for molecular visualization, VMD. OpenSpace is an astro-visualization framework designed to contextualize scientific data of our known universe. It is designed for displaying a variety of data sets in immersive environments covering vast scale throughout the universe. In Moliverse, OpenSpace serves as the foundational visualization framework. VMD stands for Visual Interactive Analysis of Molecular Dynamics. It is a software facilitating the rendering and analysis of molecular dynamics simulations. It is designed to integrate both the visualization and the analysis of molecular dynamics in the same environment, while being flexible and interactive. In Moliverse, VMD's backend library, MDLib, is used to load, process, and render molecular data. Utilizing the same time and camera enables seamless composition of these vastly different scales. Use case 1, Atmosphere of Titan. Using the navigation tool of OpenSpace, we can travel in the universe and fly to Saturn. Let's aim at Titan, the only satellite of the solar system with an atmosphere. Let's fly through it. Titan atmosphere is primarily composed of nitrogen, 94%, methane, 5%, and hydrogen, 1%. At its surface, the temperature is minus 179 degrees Celsius. And the atmospheric pressure is 1.5 times that of Earth. At altitudes between 15 and 30 km, the methane molecule condenses to form clouds. At this altitude, methane molecules are excited by the sun's ultraviolet radiation and react with each other to form ethane. The ethane molecule condenses at altitudes around 40 km to form clouds. At this altitude, the temperature is minus 202 degrees Celsius. Use case 2, molecular exhibits. Moliverse allows to render several simulations at different points in space and to travel between them to show, for example, a progression in the complexity of systems under study. This is a simulation of a chain of 15 alanine amino acids. Using the rendering functionality of MDLib, we can use different representations such as ribbons and different coloring, exemplified here with different colors per residue. We can see that this chain is quite flexible. Let's now focus on another system composed of phospholipase A2 protein to which an aspirin molecule is binding to deliver its anti-inflammatory effect. The protein is represented in ribbons and the aspirin molecule in van der Waals representation. The color code illustrates the secondary structure of the protein. Alpha helices are represented in green and the beta sheets in blue. Zooming out from this simulation, we can see the neighboring simulations, putting them in context. Let's now aim to our final simulation, an amyloid fibril found in the brain of patients suffering from Alzheimer's disease. Those structures are caused by misfolded chains that aggregate and will, with time, impair the normal functioning of the brain. Those structures are largely due to the formation of beta sheets illustrated in blue. Approaching the amyloid fibril, we can see the fluorescent markers used for the detection of those fibrils. Let's examine the groove of the protein using the navigation functionalities of OpenSpace. We can switch to a van der Waals representation of the protein to better illustrate the interaction with the fluorescent markers. Lastly, we can look back and see all of the simulations in the same context, highlighting the relative size of the presented structure. Thanks for watching.